Alex.
He is a research software engineer at INM-7, working on linked metadata tools in the general domain of fair data management. About a decade ago, he swapped sunny Cape Town for the cloudy Netherlands for reasons he is still trying to figure out. Perhaps metadata has the answer. Please provide a warm welcome for Stephan.
Yeah. Cool. Hi everyone, thanks Alex. I'm Stephan, and I'll be talking about this, and there are loads of names on there of people who contributed to this and kind of drove this effort forward, so feel free to speak to them as well. These are acknowledgements. Everything I'll be discussing wouldn't be possible without this support from collaborators, funders, and also the fact that it kind of grew out of the DataLad project is somewhat meaningful. So why am I here in front of you? I will be talking about tools that we have developed over the past more or less year and a half, pretty much since the previous distribits. And so we developed a bunch of tools and we started integrating with other tools and using them and deploying them. And I think it's really cool, and hopefully at least one person in this group also thinks it's really cool, and then my talk would be successful. But please note that this is a fast-moving train, or sometimes fast, sometimes a normal speed. And what I'm presenting to you is a snapshot. So things will constantly change, as they should, and improve, hopefully. But yeah, the state, if you look at it tomorrow, a week later, might be different from exactly what I present now. So we're operating in our team, the psychoinformatics group, at INM-7 at Jülich, for Center Jülich, in the space of fair data management, which we've heard quite a bit over the past 2 days. And this tools that we're focusing on is pretty much mostly in the area of the findable part of FAIR. Specifically, data discovery. How can we build tools and use tools to improve that? And also what I'm doing today is pretty much giving an update on what we've been busy with that started during the talk that Michael gave last year at Distribits. And some of you might remember this slide, which I just grabbed from his slides, where our goal was to make DataLad more interoperable with the rest of the world. So DataLad uses git-annex, it uses Git. You need an installation of those things for a runtime DataLad dataset. But we also want to make data findable. So how do you kind of marry these concepts? Well, there are existing standards out there that people use to define what their data looks like. Can we make DataLad interoperable with that? And the idea here is to kind of translate and deserialize/serialize between these formations. So you have a runtime DataLad dataset that requires a Git installation and more things. But I can also describe it in a way that is portable to other formats where people don't use Git. And maybe we can even make it easy such that you can import the DataLad dataset from a description that has nothing to do with DataLad at all. So we kind of took that as a starting point, and it became clear to us that we needed to interoperate with the rest of the world. We need to speak the same language that the rest of the world speaks. So it wouldn't do any good to ignore existing standards that are out there, and specifically things like schema.org, all the W3C standards for capturing the structure of provenance records, for saying that something is a data set, then that person means it is a data set, I mean it's a data set, we speak the same language. Let's understand this language and speak it as well, instead of creating our own standard, which isolates more. And that quickly brought us to the domain of text-based RDF, so resource description framework, where you have a semantic triple just to state information, like my data has the type DCAT dataset, and someone defines a standard that says this is what a DCAT dataset looks like. Text-based, very cool because it's portable, unlike well, it's text-based, it's everywhere portable online. If you need a DataLad dataset to run, you need all of the other installations, but if we can describe it in a way such that it can be ported as text, great. And also RDF is quite ubiquitous online in the kind of semantic web area. So by using existing standards and then using the same language, we immediately by design make the datasets interoperable. Now, what I've been saying now is basically data modeling. We're saying this is what we think our data looks like, or this is what we think our data means, or what a dataset means. And I've kind of gone into the semantic world, but also data as structure. So we need to marry the concept of structure and semantics. In the world of discoverability, we need to be able to say a dataset, I want to find a dataset that has these keywords, or that has these names, or these authors, or whatever annotated tag you add to a dataset. So we also need to create the structure, and we used LinkML, which is an open source tool to kind of go into this world. I'm breathing too quickly. So it's a nice open source tool. You can basically create very easy YAML-based data models or schema classes to say this is the structure of my data or of my object, in this case a project. But you can also tie semantics to it. So you can give that class a URI to refer to it in the future. You can also map it to existing meanings, which is great because we want to base our work on top of existing standards for discoverability and interoperability. Also, inheritance is important. So in this case, we say a project is an activity. And in our case, we can say a DataLad dataset is a DCAT dataset if we want, or we can just map it using these broad and exact mappings. Thank you, Atina. So what we did is we took what I just described, we went into this LinkML world of data modeling, and we created what we call a set of low-tech schema components with specific emphasis on it being components that people can reuse. So everything is based on and references existing standards, and then we create schema classes that use that, called the foundational schema components, and then also components that allow you to describe data in a world, in a graph-based world, where you have perhaps complex relations between different objects and hierarchies of understanding of what data means. And also then flat components, which is more suited towards generating user interfaces that I will quickly or soon speak about. And again, the emphasis is on, we didn't decide that we want a specific structure because that is what DataLad says or that is what we think is useful. We tried to go like really low tech to say, this is a thing, this is a data set, this is a role that an agent can play in a process, and then people can mix and match those for their specific domain, right? So you get an application-specific schema that you develop yourself based on these components, which ideally we hope makes it a much easier process. And something that's core to this whole component situation is the thing schema and specifically the persistent identifier. So we kind of baked the persistent identifier really low level into the schema components so that everything that inherits from these schema components also has the field, a PID or a persistent identifier. Now, sorry. What does a persistent identifier allow us to do? Bringing it back to the focus, which is discoverability. It allows us to link information to a specific thing that allows you to find information across contexts or across domains. So I could be a subject in a research study at a research Center Jülich, like me as a person, but there could also be different contexts where someone wants to refer to me as a person, like for personnel management, if someone wants me to get a raise or something. So the cool thing is that if we would want to discover these facts by cross-linking, that PID is the way to do that cross-linkage. But of course, sometimes you do not want to discover it. So you don't have to the PID doesn't limit you, or the fact that the PID is baked into the schema components doesn't limit you in the sense that you cannot apply these things in situations that require separation. So you would say that just map the PID. So the fact that I'm the subject in a research study and the fact that I'm involved in personnel or I'm a person being managed can be completely separate, and only a set few of people with permissions can have access to that mapping. Slight detour, but it's important in the greater scheme or schema of things. Now the cool thing that we get if you model your data and if you use tools such as LinkML that can then export those schemas into different formats is you can auto-generate a lot of things. And that's the tools that we developed is basically in the space where you can read a schema that defines person, dataset, git commit, remote, whatever. Any application-specific schema then feeds into tools that I wanted to show you about. And the two that that we spent most time on is the editor, so generating a user interface that can be web-based from a schema, and then also a backend storage API, essentially. Now, the first thing is called shackle view, and we start off where the schema or the data modeling ended. So you have an application-specific schema. You generate shackle from that, which is in LinkML is just a quick command to run. Shackle is short for shapes constraint language, and is essentially a schema constraint language for RDF graphs. So you can say that a specific data object has what they call a shape. It needs to be of this type. It has to have a keyword that's a required property that has so many minimum amount of elements. It has to have an email address that adheres to some constraint as to whatever the domain might be or whatever the string would be validated as. So all of these validations are embedded into the schema, the shackle shapes, which come directly from the schema. And then we have this tool called shackle view, which takes that schema and the deployment, which I'll show you soon, basically renders a user interface where people can edit data, add information, link specifically across object, and then have all of that metadata in text format available. So this is an example of what such an editor could look like. In this case, we have a DataLad dataset that we made of a scientific dataset that describes penguins. And in this scenario, where what am I showing here? This is the schema that we use to define what all the concepts would be in this interface. And this is the exported shackle. And if we look at the example here, we have all the class types at the site. So people can look at datasets, they can look at distributions, and you'll see everywhere there's a persistent identifier. And you can link between things. You can see there's exact mappings that go to actual ontology descriptions of these objects. And I forgot what I recorded. Okay, this shows editing an actual data object, which you can also add like more data. You can see validations being done in real time. I have 5 minutes left, thank you. And you can save and submit, which should happen soon. Yeah. It should work. Yes, thank you. Thank you, previous me. So that save and submit part directly links into the next tool because we edit that data. It's all local in the browser client. It needs to go somewhere to persist. And for that, we developed this thing called dump things, which is basically a way to just store all that structured and semantic metadata somewhere. And again, it starts from the schema definition. You can use LinkML then to export Pydantic classes, and then it basically puts the Pydantic classes together with Fast API and creates a backend system that you can retrieve information from, you can push information to. It has cool features like different storage backends, like actually seeing the structured record that someone submitted on the file system is possible. You can get it in JSON, but also in Turtle, so RDF format. And then also have permission sets. So this user is allowed to write to that collection of data. This user is not. That collection is public, so everyone can fetch that collection. So you have a lot of control over how you expose certain subsets of data through this tool. And we have a very close connection between the dump things API and then the shackle view front end to manage this information. And this is just also a quick demo to show. Here we have like file formats. That is the type, so that's the class, which maps exactly to an endpoint on the dump thing side. So I can use curl. I get information there. It shows me 2 records, which 2 records are also visible there in the front end. And then I think I showed also that you can edit these things and submit them again. You can also delete records. You can get records by persistent identifier. So not only give me all the records that are datasets, but give me that one specifically. Yeah, I'm going to skip the rest of this. It just shows the same thing, that this is an API with endpoints that are quite, in my opinion, not too difficult to use. So, where do we end up with this old stack? I have 2 minutes left. Not according to my timer. So we have the whole stack of tools that we start using, putting together, implementing in certain use cases. So, it's LinkML, you use dataset, DataLad concepts, which I've forgotten to say the name. It's actually, DataLad concepts is the idea of these reusable schema components. You develop your own application-specific schema, and using these tools that we develop, shackle view and dump things, you can immediately start using the front end for management or information editing, annotation, and then deploy the back end to be the receiver and also the point of retrieval of records. And what we've also done, because we like Forgeo, is to integrate that for token management. So you can deploy or host a Forgeo instance for your use case. You can have registered users register there, and they can kind of create their own tokens through that way that they then put into shackle view for submission or to be able to view specific records that they have been configured to view on the backend side. Sorry, yeah, this is pretty much what this slide shows. And then I'll stop in a minute and a half, according to my time. Just by saying quickly the current use cases that we have. So I showed the one which is kind of a demo site, the Penguins deployment. So we have a constant running deployment that you can, once I share these slides, you can link to that. You can start to see if you can retrieve data, etc. But then we also have the research use case, which is this TRR 379. It's a collaborative research center, and it's funded by the German DFG. And there we have loads of different groups that I think I have, yeah. There it is. So it's kind of different research groups all involved in broadly the same idea of research, but they all have like idiosyncratic processes and different infrastructure setups. And the idea is not to take the stack that we just showed and replace everything that people have. It's kind of a tag along, because it is self-hostable, and it doesn't require you to say that this is the way that you manage your data. We want it to be portable, so you can have a shackle view deployment that's user interface for people to add metadata on top of whatever data collection they're already doing. And then in the end, export that information as well. And we deploy that already. One is the, let's see, DFG contributor survey tool. Oh no, it's not. There it is. So we've actually run this deployment for a few months now, where people have to annually input information that the DFG requires for funding purposes. And usually it's a PDF form, and now we've replaced it by something like this, where we create the schema, deploy this, and we get all of the RDF linked metadata in the back. And the cool thing is that people can enter their person information, they can consent to us using it, but then link to it on the website, which is, Stephan, there, and you can see like people and projects and contributors and stuff. And by having this namespace, the website, as a way to persistently identify a contributor, we have that linkage that says, okay, we entered the information into the DFG survey app, but we also have their information on the website. We can cross-link stuff, and that is a cool application in my mind. And also, it shows you that this thing is not domain specific. So we have something that describes penguins in the Antarctic, and something that's very like personnel management type thing, and we use the same technology. I'm happy to speak about this further. I have to stop now. Thank you.